Hey Josh, I hope you're doing well and staying safe during the coronavirus. Here's our presentation on impacts of marine plastics. As you may know, the world's oceans are currently facing a variety of issues, and one of those issues is particularly harrowing: marine plastics. The study we have chosen takes a holistic approach in order to explain the ecological impacts caused by marine plastics. Such consequences will be thoroughly explained, and the implications of said consequences will be explored.
Marine ecosystems provide a large amount of services to human civilization, including but not limited to food for billions of people, carbon storage, waste detoxification, and jobs and opportunities for livelihoods. Damage to these ecosystems will inevitably harm the global population in one way or another. We could see significant losses in food security, jobs, health, and income. Harm to the health of these ecosystems is not to be taken lightly.
An estimated 4.8 to 12.7 million metric tons of plastic entered the oceans from land-based sources in 2010 alone, with the flux of plastics entering the ocean being predicted to increase by an order of magnitude within the next decade. In other words, there will be around a 1,000% increase of plastic in the oceans. Removing said plastic is time-consuming, expensive, and inefficient. Removing some of it is possible, but the task is difficult.
It is now well documented that plastic negatively affects marine life and ecosystems. The amount of research on the matter has grown exponentially. However, there's still a general misunderstanding when it comes to overall impacts of marine plastic. Unfortunately, much of the research done tends to be local and hard to scale. The issue is still global, however, so a synthesis of the available information is necessary, as well as a translation of said information into societal and economic terms.
A general understanding of the impacts caused by marine plastics is necessary if we seek to change our behaviors and mitigate the problems presented. New legislations and rules would have to be made, along with changes to governments, industries, and commerce. A general understanding is integral for the global negotiations that will have to be made. Here's a chart here. We have a bubble of the source of plastics, then that goes to the distribution of marine plastics. And we have the ecological impact synthesis. It's a self-explanatory chart, but it's a visual that not a lot of people understand when it comes to this environmental issue.
Around 8 ecological subjects form the basis of the study. Scores are based on the extent of the impacts, the reversibility of the impacts, and the frequency of the impacts, where impact is defined as an effect on lifespan and/or reproductive potential. Such subjects include birds, turtles, bacteria, plankton, algae, fish, mammals, and invertebrates. A summary of the data indicates that there is global evidence of impacts with medium to high frequency on all subjects, with a medium to high degree of irreversibility.
Except for algae and bacteria, the ability of the impacts negatively affect the subjects involved. For algae and bacteria, there's an increase to the range of habitats available for colonization, which enables the spread of these species to new areas, thus increasing their range and abundance. This causes a different set of problems to the marine ecosystems.
With the exception of the regulation of the chemical condition of salt waters by living processes, all ecosystem services are adversely affected. This includes provisionary services such as food and aquaculture, regulatory services such as climate regulation and pest or disease control, and cultural services such as education and the sciences.
As previously stated, marine ecosystems contribute significantly to human welfare, so damage would endanger said welfare. Seafood is a principal source of protein globally, representing around 20% of the food intake for 1.4 billion people, 19% of the global population. Marine plastics can reduce the efficiency and productivity of commercial fisheries and aquaculture through physical entanglement and damage, as well as posing a direct risk to fish stocks. Plastic is frequently ingested by a wide range of species vital to food provision, including fish and shellfish, at all stages of their life cycles.
It's important to remember that plastics can accumulate in animals higher up the food chain as predators consume prey that have ingested plastic. The contamination of the food chain with plastic and associated contaminants puts fish and shellfish stocks and their prey at risk of lethal and sublethal harm, with there being the capacity for impacts at the population level. This also applies to humans as well. While further studies are needed to better understand the risks of consuming plastics, existing literature points to the health risks of plastic being minimal. Nevertheless, it's still an issue for most animals, and the perceived risks of contamination can put fisheries at risk.
Evidence suggests that the productivity, viability, profitability, and safety of the fishing and aquaculture industry is highly vulnerable to the impact of marine plastic, particularly when coupled with broader factors including climate change and overfishing. The high dependency on seafood for nutrition leaves the well-being of a significant proportion of the world's population highly vulnerable to any changes in the quantity, quality, and safety of this food source. There's also the issue of the potential loss of available jobs or livelihoods due to above consequences.
Beyond the immediate ecological impacts documented, the presence of plastic has the potential to dramatically shift the ecology of marine systems. An altered environment and shifts in biodiversity can have potentially wide-reaching and unpredictable secondary societal consequences. Plastics are stressors, meaning they can act in concert with other environmental stressors, such as those arising from other pollutants. Changing ocean temperatures, ocean acidification, and the overexploitation of marine resources. The cumulative impacts of these stressors may result in marine plastic causing far greater damage than what is currently documented.
Although the study shows increased bacterial and algal colonization in abundance, this causes its own set of issues, as previously stated. The colonization of plastic provides a mechanism for movement of organisms between biomes, thus potentially increasing their biogeographical range and risking the spread of invasive species and diseases. Marine plastics has been linked to increased rates of invasive species and unprecedented rates of species dispersal.
On a global scale, it has been estimated that marine ecosystem services provided benefits to society approximating to around $49.7 trillion per year, and that was just based on 2011. While limitations in its accuracy are acknowledged, this figure is considered to provide sufficient precision for global analysis and an estimate of the decline in its value due to the presence of marine plastic can be taken as a first-order approximation of an economic cost.
The economic costs of marine plastics as related to marine natural capital are conservatively conjectured at between 3,300 and 33,000 per ton of marine plastics per year. Based on 2011 ecosystem service values in marine plastic stocks. Given this value includes only marine natural capital impacts, the full economic cost is likely to be far greater.
So now we can talk about the potential solutions. So multiple actions are proposed within the study in order to help solve this crisis.
It is recommended that a systematic global research agenda for the recording and reporting of marine plastic research, especially relating to the most vulnerable and valuable ecosystem services and on the potential contamination of the human food chain, is established. It is also recommended that we undertake further research on the heterogeneity and timescale of impacts in order to enable the efficient development of future policies and regulations.
The calculation of the economic cost per ton of marine plastic is fundamental in future global negotiations to change the way plastics are designed, produced, used, reused. Costs and risks rate will be to convince people and organizations to change.
Since the majority of marine plastic takes decades, if not centuries, to fully degrade, and given annual increases in plastic production and losses to the environment, between the 2011 and 2017, an additional 28 to 71 million tons of plastics are predicted to have been added to the marine environment from land-based sources. It is likely that the negative ecological, social, and economic impacts of plastic pollution will continue to increase well into the future. The evidence presented here demonstrates that by acting to reduce marine plastic pollution, society would be investing in both the current and future provision of marine ecosystem services and the human benefits they provide.
Once this issue is solved, there will be visual changes. For starters, beaches will be clean and the beauty of natural aquatic habitat will be preserved.
Here's another visual on the marine plastic issue. It's overlooked that marine plastics are making their way into the aquatic food webs and are consumed by fish. We use fish as a food source, so by them consuming plastics, they're getting into our food source, and people aren't thinking about something that they could be consuming. Another visual here, a little diagram. You have the bags that are going to the ocean, bottles, everything, and all the metric tons of pollution it's causing in the oceans. There's one more chart that explains it all. You have the pollution coming from the land. You have marine animals ingesting it. The plastics going out deep into the ocean. It's all things like cigarette butts, bottle caps, straws, cups and plates, single-use bags, food wrappers, any kind of beverages and bottles. And that's the true impact on marine plastics, something that's very overlooked. And thank you for listening to our presentation.